Righto guys, I know what you're thinking. What if we can't find the x-intercepts by factorising because it can't be factorised? Well, let's check out a worked example that addresses just this, shall we?
Alright, so it's now time to sketch the graph of y equals negative 2x squared plus 3x plus 8 on the set of axes provided. Now, as you're going to see in a couple of minutes' time, this isn't actually like the ones that we've just done where we need to go through and complete the null factor law, because what's going to happen is you can't actually factorise this. So let's go through and prove that first of all. Alright, so the very first step is to find the y-intercept. So let's go through and do that. You got y is equal to negative 2x squared plus 3x plus 8, and of course to find the y-intercept, we make our x equal to 0. So let's go through and do that. Now we go y is equal to negative 2 times 0 squared plus 3 times 0 plus 8, which of course will get us y equals 8. And that means that our coordinate of the y-intercept will be at the point 0, 8. So plot that point now, we go up to the point 0, 8, and we put a little dot here and write 0, 8 just here like that. Alright, the next one is to find the x-intercept. So to do that we need to make y equals 0. So x-int y equals 0. Now, of course, we've got two types of x, that is x squared and our x, so therefore we're going to need to look to factorise first of all. And of course we've got three values, so that is our a value being negative 2, b being 3, and c being 8. And we can't actually take any common factors out, so we need to look to see if we can factorise in any other way. So let's just write out the equation. We go y is equal to negative 2x squared plus 3x plus 8. And let's look to factorise. Well, negative 2 times 8 is negative 16. And are there any factors of negative 16 that add to 3? No, there's not. So that means what we need to do now is use the quadratic formula. Now the quadratic formula is equal to x is equal to negative b plus or minus the square root of b squared subtract 4ac on 2a. Alright, so let's figure out our a, b and our c values. Well, our a is going to be negative 2, our b is going to be 3, and our c is going to be 8. So let's substitute that in now. So we get x is equal to negative b, so that's negative bracket 3, plus or minus the square root of b squared, so that's 3 squared, minus 4 times a is negative 2, times c is 8. We'll just continue the square root sign over there. Now that is all going to be over 2 times a, which of course is negative 2. Alright, this is going to require a little bit of simplifying now, so we get this here is equal to negative 3 plus or minus the square root of 3 squared is 9, negative 4 times negative 2 is 8, times 8 is 64, so plus 64, over 2 times negative 2 is negative 4. This of course is equal to negative 3 plus or minus square root 9 plus 64 is 73 over negative 4. Let's just bring it up here now. Now we can't actually simplify this other than taking out the negative, so we get x is equal to 3 plus or minus the square root of 73 over 4. So we can write that as x is equal to 3 plus the square root of 73 over 4, or 3 minus the square root of 73 over 4. Alright, so if we go through and do that now, we write it out as x coordinates. So our x coordinate here is 3 plus root 73 over 4, comma 0, because that y is 0, or 3 minus root 73 over 4, comma 0. Now, of course, when it comes time to plot that, we don't actually really know where that is. So what we need to do is we need to go through and just plug this into our calculator and press Control Enter, which will then give us our approximate answer. Now, when we do that, what we're going to get is we're going to get two coordinates. The first one being for the plus root 3 plus 73 root 73 over 4 is 2.89, comma 0, and this is an approximate thing because the root 73 of course is an exact answer, and negative 1.39, comma 0. That there will make our life a whole lot more easy in terms of plotting these points. So what we're going to do here is we're going to come across to negative 1.39, which of course is just going to be around about here, and we're going to draw a dot. And then we're going to go over to 2.89 at 0, so 2.89 is around about here, and we're going to draw a dot. And we're not going to write 2.890 and negative 1.390 because they're not an exact value. So what we're actually going to write is the 3 minus root 73 on 4, etc. So to do that, I just come over here and I write 3 minus root 73 on 4, comma 0. And I go 3 plus root 73 on 4, comma 0. Alright, now I've got my two x coordinates. What I now need to do is find my turning point, of course. So I find my turning point by doing turning point is equal to negative b on 2a, comma c minus b squared over 4a. Substituting in now our negative b, so our b value is 3, so you get negative 3 on 2 times a, so 2 times negative 2, comma, c being 8, minus b squared, so that's 3 squared over 4 times negative 2. Just bring it up here now. So therefore this is equal to negative 3 over negative 4, which of course is equal to 3 on 4, because negative 3 here, 2 times negative 4 is negative 4, so that gets the negatives cancel out, so that gets us 3 on 4, comma, 8 minus 9 over negative 8. This therefore simplifies to get us 3 on 4, comma, 8 plus 9 on 8, which of course is 3 on 4, comma, 9 and 1/8. Because when you add 8 plus 1 and 1/8, you get 9 and 1/8. So let's go through and plot that point. So 3/4 over here, that's going to be 9 and 1/8, which is around about here. And we're going to write the coordinates of that point, 3/4 and 9 and 1/8. Right here. Alright, now as you can already see, it's going to be a maximum parabola because it's going to come up here to its turning point and then come straight down. Right, let's just double check though that it is a maximum parabola, and of course I do that here by coming over and checking out the negative 2, and because it's a negative, well yes, it is going to reach a maximum point and then go down. Alright, so now all I've got to do is basically join the dots, so let's go through and do that. So I go up through each one of the dots, make sure it's got a round top at the very top point, and down like that. And of course I draw arrows at each end, so it shows that it's actually continuing on, and I write out the equation of the line, that is y is equal to negative 2x squared plus 3x plus 8. And there you have it. That's how you get your quadratic function when we can't actually factorize to find the x-intercepts. You actually use the quadratic formula. Alright, now it's time to press pause once again and attempt the following question. That is, sketch the graph of y equals x squared plus 3x minus 8 on the set of axes provided. Of course, when you're done, make sure you press play and check your solutions against mine. Alright, so welcome back once again. So the very first step that we need to go through and do is find the y-intercept. Now of course to do that what we need to do is make x equal to 0, so I've written out the equation here, and I've made x equal to 0 as you can see here, x equals 0 and x equals 0. Now 0 squared plus 3 times 0 of course is 0, minus 8 is negative 8. So we get the coordinates 0, negative 8. And let's go through and plot this point over here at 0, negative 8. Of course what I now need to do as well is write out the coordinates of my intercept, that is 0, negative 8. Right, now I need to find my x-intercepts, and to do that I need to make y equal to 0. So I've written out the equation but with y equals 0 now. And of course now I'm looking to factorize like always in order to be able to find my x-intercepts, because that's going to be the easiest way to do it. So to factorize, I've only got a value for 1 for the a out the front of the x squared, so I can look to use a cross method now. And to do that I need to write out the factors of c, that is negative 8, and look for any that look for b. So doing that now, I have written out the factors of negative 8, negative 1 times 8, negative 2 times 4, negative 4 times 2. And of course none of them actually add to b, none of them add to 3 that is, so what I need to do is then go through and use the quadratic formula in order to be able to solve. Here I've written the quadratic formula out as you can see, and I'm substituting in all of my values now. So my b once again is 3, 4 times a is 1, and my c is negative 8, which of course I got through from the equation up here, over 2 times 1 because my a is 1. Going through and simplifying up here now as you can see, negative 3 is negative 3 of course, plus or minus 3 squared is 9, negative 4 times 1 is negative 4 times negative 8 is positive 32, over 2 times 1 is 2. So you get negative 3 plus or minus the square root of 41 on 2, which can be written as negative 3 plus root 41 on 2, or negative 3 minus root 41 on 2. Now these as coordinates will end up being negative 3 plus root 41 on 2, comma 0 because our y is 0, or negative 3 minus root 41 on 2, comma 0. Now of course once again this is difficult to know exactly where this falls, so what you need to do is you need to actually go through and write this into your calculator and press Control Enter, and it will give you an approximate value. Of course now that I've done that, what I'll end up getting is an answer that looks like this, negative 4.7, comma 0, and 1.7, comma 0. Now of course that there is a lot easier to go through and plot, so let's go through and do that. So I go 1.7 here, so it's 1.7 which will be over here roughly, and of course I'm going to use my exact value, so that will be negative 3 plus root 41 on 2, comma 0, and my other value, that is at negative 4.7, so negative 4.7 which is around over here, put that over there like that, and I'm going to write the exact value once again, which of course is negative 3 minus root 41 on 2 comma 0. Now that I've gone through and plotted those points, the last thing I need to do is go through and find out my turning point. So I've written out the formula for the turning point here, substituting my b value being 3, my a being 1, my c being negative 8, my b once again being 3, and my a being 1. Going through and simplifying now, I get negative 3 over 2, negative 8 minus 3 squared is of course 9, over 4 times 1 is 4. Simplifying even further, so you get negative 3 on 2, and I've changed negative 8 to get a common denominator with the 4 here, so negative 8 is the same as saying negative 32 divided by 4, because negative 32 divided by 4 is negative 8, so it's still the same thing, but now I can add the fractions, or subtract the fractions really. So you get negative 32 on 4 minus 9 on 4, which of course is equal to negative 41 on 4, and when I convert that to a mixed number so that I can know where to plot it, I get negative 10 and 1/4. So I'm going to come across to here, 3 on 2, which is negative 1 and 1/2, all the way down to negative 10 and 1/4. Now this is going up by 2, so that's 1 here, so that's negative 9, negative 10, this would be negative 11, so negative 10 and 1/4 will of course be over here, and negative 1 and 1/2 is here, so I plot the point. And once again, of course, I go through and write out the coordinate of that point there, the turning point that is, so you get negative 3 on 2, comma, negative 10 and 1/4, just like that. Once again, I now need to double check that I've got my quadratic function, that it's going to be a maximum or a minimum. So what I need to do to check that is I look at the number at the front of the x squared. Is it positive or negative? Well, it's positive, as you can see just here, because there's no negative out the front. And when it's positive, it means it's a minimum parabola, because it will end up going up. So it starts off, as you go towards the left, it's going up, and as you go towards the right, it's going up. Alright, so of course now that I've got all my points, what I can go through and do now is just join all the dots and basically sketch the graph. So to do that, I just come down through here, making sure I go through each one of the points, down around to the bottom there where the turning point is, up through the Y-intercept, and up through the X-intercept. Now of course, it's extremely important that you do make a nice rounded bottom down here, and that it's not like a triangle shape like that, like some people do, because it really needs to represent what is a parabola. So basically what I refer to this as is the Beyonce graph, because it's got a nice round bottom down here, as you can see.
Alright guys, thank you very much for tuning into today's lesson, which is all about how to sketch the graphs of quadratic functions by finding the x and y intercepts first. Now make sure you stay tuned for the very next lesson, because we're going to cover how to sketch these functions but using the turning point method. So like always, make sure you say hi to your maths teacher for me. Wazzy out.